and welcome back. Another horrible cold day, snow still on the ground, chucking it down with rain, and it's bloody well freezing in here. Anyway, we're back on this 6146 amplifier. Well, let's bung a signal in it. It's not doing it. Where are we? Frequency 1 kilohertz. Amplitude 0.5 volts. Right. I just had an interesting phenomenon. I had this. And look at that. The output. Now watch. This is my ground bus. I'm going to ground it to the chassis. And that stopped all that malarkey. Right, let me show you what I'm monitoring. We're monitoring here, look. We're on our moving capacitor reservoir. I can never remember which is which. One of them anyway. That capacitor here. Right, so I'm on there, right. Spikes. This is magnified, so we're on about 0.1. We're about 100 millivolts per div, 300 millivolts per div. I don't think you can hear it, but I can hear it. It's like a hum. So anyway, when I ground the chassis, we don't get any of that. Right, I know it's really hard for you to see everything because we've got freaking wires going everywhere. Anyway, let's crank the bugger up now. We've got it sort of going right. Ooh, yeah, what's going on? Okay, that's upset me thingy, look. Frequency, where am I? 1 kilovolt. Amplitude, sorry I keep sniffing, 1.5 volt. Sorry I keep sniffing, it's that cold in here. Right, I'll try not to keep sniffing. There we go. Nice output. Only 0.1 volts. Can you look a bit more? Ooh, yes, keeps going. Right, well, got to get this bloody test sorted out. Test setup sorted out. Right, well, we're still not cooking with gas, are we? And now we're getting a lot of distortion. That's, ooh, look at that. I think that's crossover distortion. Let's have a look at that. What's THD? Distortion 12%. 8%. Right, I think a lot of that is because I don't know if you can see there, we're getting crossover distortion or something going off there. Very pointed peaks. I think we can try and sort that out by altering the bias on the valves. And then to do that I've got a wrist swipe and limp, sticking my fingers in high voltage places. Right, okay, that's over there. Right, that means we've got minus 38 volts on one cathode. Let's knock that down, or up, depending on your prevalence. Oh, that's the one bleeding one. 37, let's knock that down to, yeah, 30. Okay, we've got it working. It's working quite good actually. I hope you can see through all these bloody wires. Poke you there. So, crank it up. This is without any negative feedback. We're getting 11 volts RMS. It's starting to clip there. That's at 14 volts RMS. Just have a look at the distortion. 4%. Let's knock that down. Now then, this is with the screen grids at 180 volts. That's as per the data sheet. Now then, if we crank that up to 120, and that's a little bit of problem. Mind you, we've got -30 bias. That's taking us up a bit higher. That is. That's 95 milliamps. Quite. Well, hold on. What am I talking about? That's 85 milliamps quiescent. And then let's just have a. There, we're starting to clip there. Look. And that's at 17 volts RMS. Quite high distortion. So, just leave that running a bit. At about, let's call that 1 watt. We're getting less than 1% THD. We're getting 0.2. Let's see where that starts to rise. Let's have a look at the frequency response. I know it's going to be pretty terrible. Let's put that up there. See if I can get that line sharper. Mind you, you'll be able to see it nice on camera. Right, so where are we there? We're at 1 kilohertz. Let's knock it up to frequency 10 kilohertz. Yeah, it's still there, look. Frequency 20 kilohertz. Yeah, it's still there, it's still good frequency response. Frequency 30. Yeah, just started dropping there, look. So even without any negative feedback, it's quite good. Now let's go the opposite way. Frequency 100 hertz. Just have to change the time base. Yeah, I know it's not going to be. We haven't really got a. What do you call it? There's no trigger on this. Right, but that's still 2 dibs. Let's go down further. Frequency 50 hertz. Oh Jesus. Yeah, that's starting to distort. Look. Let's have a look at distortion. 5%. So let's just muck about with that. Hold on. Frequency 100. Oh shit. That's 100 kilohertz, you peanut. Frequency 100 hertz. Yeah, and it's still 2%. Frequency 150 hertz. 1.5, yeah. So at lower frequency, just knock that back up to 1 kilohertz. No, let's knock it down to 440. Frequency. Don't go in one ear and out the other without scarifying the brain. Where was I? Yeah. Low frequency response, not very good. I'll tell you what, let's go and chuck some. I've got to power it all down. Let's put. I don't know how I'm going to do that. Let's put a speaker on there. Let's play some music. Here we go, a bit of that. Very quiet though. No hum at all. Even with all those wires everywhere. Anyway, music. Bit of Dr. Alamontado. Oh, oodles! The bass. Those audio samples didn't really do the amplifier justice. It's got quite nice bass response Obviously the high frequency response pretty good, and as you saw from the plots of the quick frequency response test, the frequency response are quite good as well, which is nice to know. So normally in the past what I would have done is like messed around with that sort of temporary test setup quite a bit more, but you can mess about like till, you know, and just end up going around in circles. So sod that. I've basically moved on to trying to now build an actual proper amplifier, and then I can always tweak the design further when I do so. So what I've got on the bench in front of me at the moment is all the iron, the big old mains transformer, the 2 output transformers. I've just whacked a couple of bases and some other bits and bobs here just to give us a rough idea of what sort of size we need. Now I did mess about with these end bells trying to get it so that I could stand the output transformer up to give us more room. However, I don't know if you can see that isn't going down. There's no way that's gonna fit on there. And then I did think about making some sort of padding here. Nah. So I'll end up mounting it like that, which will do just as well, because, and it's not really getting in the way of anything there, it's got to be orientated differently to these output transformers anyway, so that the magnetic field doesn't interfere. So we should be alright like that. I hope so anyway. I'm just going to have to check that, get my head around that in a minute. But with it like that, and the output transformers there, then we've got to try and keep those 2 output, these for the output valves, got to try and keep them near to the output transformer. The driver for the 2 output valves, it would be twin triode, cathode follower, that needs to go next to them, quite near to those, so that we've got a small distance for the coupling capacitors and what have you to go there. And then basically all we've got then is phase splitter. This is representing our input, so double triode, one for the left, one for the right. And then I had it in mind to make a valve tone, is that the right word? A valve tone stage. Looking online, it's basically, you can just use something like 1 12AX7, 1 ECC-AE8T3, something like that. So that's what that's representing. So with A, we've got, if we run down to here to there, that's about 10 inches, and that'll be 14 inches across. That'll be our chassis. Now then, we need it to be quite deep, because we've got all this McGubbins to put in there. I did think about buying some capacitors, say something like 450 volt, 330 microfarads, which would be about what these are. However, I've got loads of these. I've got a bag full of these, so might as well use them. So if we can squeeze them in to the chassis, then we'll do so. So we've got this big old choke. If we wanted to put that on top, I don't know, it could maybe sit something like that. But I think what I'd prefer to do is make the chassis a bit deeper, say something like 4 inches deep, and then that's where we can fit all this McGubbins in there. Then that's 3.5 inches, or if we mount it that way, 2.5 inches. If we can stick that underneath, then we'll be about right. So that will go, all that lot there will sit sort of like that underneath that. And the only problem we're doing the mounting a transformer like that with it dropping through is we've got what? Yeah, that's about an inch. So we've got to add an inch. Yeah, I think we can just about get away with that. So I'll measure that up all properly, but basically I now have a rough idea of what size sort of metal we've got to cut and everything. So we can crack on and do that. Now then, the only other thing that we need to do is to wind it. We've got to have another transformer for the screen grid supply and the bias supply and maybe the heater supply for the sort of input valve and tone stack circuitry. So I am going to wind my own. I've already started on that. We'll have a look at that in the next video. And so, without further more ado, I'll shut up waffling. Thank you very much for watching once again, and ta-da for now.